Hi, I'm M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. I welcome everyone to this discussion. Today, we are going to discuss predicting a student's performance using deep learning. And the scenario of this discussion is a school wants to predict student performance to provide a yearly intervention and improve academic outcomes. So this team going to discussing the feasibility of using deep learning for this task. So Anu going to start this session by explaining the problem statement.
Yes, ma'am. I'm going to act as a data scientist in this role play. So the school is struggling to identify the students who are in the risk and falling behind. So we want to use the deep learning to predict the student performance by their historical data and provide early intervention. I'm Kirtika. I'm going to act as a role software engineer. I have been reading about recurrent neural network, and I think we can use them for this task. What do you think, Janisha? I'm Janisha, and my role is education expert. Yes, that's great idea. We have a lot of sequential data, such as students' attendance, grades, and assignments, and RNN can help us model these sequence and predict future performance. Hi, Pratika. My role is school administrator. I have been collecting data on student performance, including grade, attendance, and demographic information. I have around 5,000 students record will that the L2.
Okay, can anyone tell about recurrent neural network and then apply where it is in a sequential data?
An RNN is a type of neural network that uses recurrent connection to process sequential data. It's particularly useful for modeling temporal dependency of data. That's a good start, but we might need more data to achieve a high accuracy. So we can also use the technique like data augmentation and transfer learning to improve the model's performance. That sounds like what we need, but how do we handle the missing data? We can use the technique like main imputation and regression imputation to handle the missing data. We can also use the technique like masking that ignores the missing data in RNN.
That's a good suggestion. Can anyone tell what are the challenges we face during deployment in this protection?
Okay, ma'am. One issue that the model might not generalize well to new students or academic years. We can use techniques like cross-validation and ensemble method to improve the model robustness to new data. And another challenge is that this model does not provide us a correct result. How do we understand that what's driving the prediction? We can use the technique like features importance and partial data dependency, not to understand the relationship between the input features and the prediction.
Let's discuss some potential points. Can you suggest some more points to how to improve the interpretability?
Yes, ma'am. We can use technique like shape values and line to provide insights to improve the model prediction. Yes, that's great idea. But how can we understand that the model is fair and unbiased? We can use the technique like fairness matrices and bias mitigation strategy to ensure the model is fair and unbiased.
Excellent discussion. Let's wrap up the discussion here. I hope you all have a better understanding of how deep learning can be applied to predict student performance. And here our task is to develop a simple recurrent neural network model using Keras and TensorFlow as we work already in a machine learning lab to predict student performance based on historical data. And here, what we are going to select data for 5,000 student records with the grades, attendance, and demographic informations. And second, the sequential data of students' attendance, grades, and assignments here. And what are the deliverables here going to predict here is working prototype of a predictive model, and then presentation outlining the approach about the architecture and what are the results we get from the data. A report detailing the implementation and future work, and then last a plan for deploying the model in production and ensuring its fairness and interoperability. So thank you everyone.
Thank you.